Okay, day two, quick recap. There's an elf with a bag of colored cubes. And assuming that there are only 12 red cubes, 13 green cubes, 14 blue cubes, we're supposed to determine which ones of these games would be impossible to play, where he pulls out hands full of these cubes. So obviously we have to check if any of these numbers are bigger than the ones we have down here. And we can clearly see in game 3 there's 20 red cubes. This should not be possible because there are only 12 red cubes in the bag. Here we have 15 blue cubes. That should not be possible. We only have 14 blue cubes in the bag. So basically what we're doing to solve part 1 is basically just iterate the lines and then see if there are any numbers that are higher than the maximum amount allowed for that specific color. So we're going to create a hash map where the colors are the keys and the max value, 12, 13, and 14, are the values. Finally, if we've determined if a game is possible or not, we take its ID, which is this number right here, game 1, game 2, game 3, and we add up the IDs of the possible games. Here, since this game and this game are impossible, we add up 1, 2, and 5, which adds up to 8. So let's see how we're going to do this in Python. So we start off by creating the hash map of possible values for each color, where the color names are the keys and the max value are the values. We initialize a return value called total at 0, and then we're just going to iterate the lines, but we're not just going to iterate the lines themselves, but also their index. That's why we use enumerate. So we get game 1 as game 1, game 2 as game 2. Because Python uses 0 indexing, not 1 indexing, that game 0 gets the index 0. Game 1 gets the index 0, game 2 gets the index 1. So we have to correct for that by inserting the keyword start and put that at 1. This way it'll start counting not at 0 but at 1. Now we'll iterate all the number color combinations that we find in that game, and for this we're going to use regex, the regular expression module from Python, and we build this little regex right there. So we use two pairs of parentheses because we want to capture two elements, first the number and second the color. For the number we use /d plus because d is digit and the plus says it can be more than one digit because, for example, number 20 has 2 digits. And in the second group we just write out the names red, green, blue, and we separate them with the OR operator, the vertical line. So let's see if this works. And it does not because we have to import the module first. And it still doesn't work. We have to actually input the thing that we're iterating over. And now it works. But keep in mind the numbers are still strings. We have to use the int method to turn the number into a number, the string into a number, and then compare it to the maximum allowed value for that specific color using the hash map. So what we're trying to find is a single number that is bigger than it should be. If there's one number that's bigger than it should be in a game, then the whole game becomes impossible. So for this, it's very useful to use the word break. If we use break inside of a for loop, it will stop the for loop altogether. It'll continue after the for loop. And we can implement something which I believe might be specific to Python. I'm not sure if other languages have it as well. It's called a for else loop. So we go through a for loop, and if we encounter a break, then we continue after the for loop. However, if we go through the entire for loop without ever reaching the break because the condition was never met, then we enter the else clause of the for else loop. And here we add the ID of the game, which is I, to the total. Let's see if this works, and we get the number 8, which is correct. Okay, for part two, we're interested in what is the fewest number of cubes of each color that could have been in the bag to make the game possible. We get this by finding the largest value for each number. For example, for the color blue, we see a 3 over here and a 6 over there. Obviously, the 6 is important, not the 3, because we need at least 6 blue cubes in the bag to make this game possible. We do the same thing for red. Here we see a 4. And for green, we have the 2 here. Then we take these three numbers, 4, 2, and 6, multiply them, get the number 48. Do the thing for all the other games. We get 12, and so on. And then we add those products together, take the sum of them, and return that, and that's going to be our puzzle answer. Let's see how we do this in Python. Let's just start where we left off. So we use the same kind of color number map, only the difference is we need it for every game, and we're going to call it max vals, which will keep track of the max values for each color. We're going to initialize each of these values at 0, and then iterate with the same regular expression through each game, and then update our max values for each color. Each time we have a number color pair, we look in the dictionary, is that number bigger or not? If the new number is bigger, then we input that number into the dictionary. After that for loop, we're going to add the product of these values to the total. We can do that by accessing them all individually, or what I like to do is I like to use the math module with the method or the function prod, which is product. We have to import math and just input the iterable into it. Here we're interested in the values of the dictionary, so we use the values method, and we get the right answer. So that's it, part 2.